you know Euler's method? In this problem, we're given a function f of x and we're being asked to approximate f of 3 using Euler's method when we start at x equals 0 and are using 3 steps of equal length. To do this, what I'm going to go ahead and do is I'm going to make a table. My table is going to have 5 columns, with my first column being the values of x, my second column being the values of y, my third column being the slope or the derivative of my equation, which I could represent in any notation, my fourth column being the change in y, which can be found by multiplying the slope by the step size, delta x. And my final column is going to correspond to my new y values. These can be found by taking the original y value and adding the change in y. Let's go ahead and fill out this table a bit. I'm told in the problem that I start at x equals 0, so I'll start here. And then what I do is I go ahead and take my steps according to what I'm told. So here, taking 3 steps of equal length from 0 to 3, each of those would have a width of 1, which means I go 0 to 1, 1 to 2, and 2 to 3. I'll also go ahead and fill out my y value when x equals 0. What I see is if I plugged in x equals 0 into my original function, I'd integrate 0 up to 0, which gives me just a value of 0. From here, we fill out the rest of the columns. Note that to get the values of column 3, we need to go ahead and take the derivative of our original function. Using the fundamental theorem, what we see is that f prime would just be equal to the square root of 1 plus 3x squared. Therefore, at the point 0, 0, our slope would be equal to 1, our change in y would be equal to 1, and our new y value would be equal to 1, which we go ahead and drop down here because that would be the y value that we're predicting after we've taken one step. So when we take the step from 0 to 1, we projected that our new y value should be equal to 1. We repeat the process again for the point 1, 1, and we get our new y value equal to 3. And doing it one more time for the point 2, 3, we end up with the new y value of 3 plus root 13. Keep in mind that once you get to this point, you want to go ahead and stop. You don't want to continue filling out your table. This is because you've gone ahead and found the approximate y value when x is 3. That's what we were looking for all along. So we can say f of 3 is approximately equal to 3 plus root 13 using Euler's method.